Hello guys, welcome to Ahmed Teach Engineering. This is going to be our first video in a series of videos on thermodynamics that is going to be coming out. You can go down to the description below where you will see different time codes. You can click into any time code that you are interested in, that you would like to study. Without further ado, let's jump right into the video. In today's class, we are going to be talking about the meaning and definition of thermodynamics, fundamental concepts, what are systems, types of system, properties of system, extensive and intensive property. So, definition of thermodynamics. Thermodynamics is the branch of science that deals with the relations between heat and other form of energy. Thermodynamics is both a branch of science and engineering specialty. Here at Ahmed Teach Engineering, we are more concerned on the engineering specialty. Science defines thermodynamics. Science is normally interested in gaining a fundamental understanding of the physical and chemical behavior of fixed quantity of matter. Engineering, on the other hand, focuses on the study of systems and how they interact with their surrounding. In engineering, we are more concerned on systems and how they interact with their surrounding. Engineering application of thermodynamics have helped pave the way for advances in major areas such as space travel, surface transportation, air travel, 3, space flight, 4, electricity generation, 5, improved medical practices, etc. Coming down to system. A system is defined as a quantity of matter or a region in space chosen for study, or anything which is real in the universe is called a system. Anything in which you are studying is called a system. If you are studying a book, the book is called a system. If you are studying a pen, the pen is called a system. For example, we may want to study a quantity of matter contained within a closed rigid wall tank. So, let's assume this to be the closed rigid wall tank. And there contains a gas molecule in it. And we are studying the gas molecule. So the gas molecule in the closed rigid wall tank is called a system. Another example, we may want to consider something such as a pipeline through which natural gas flows. The gas in the pipeline through which this natural gas flow is called the system. So the gas is called the system. Surrounding. Surrounding is the mass or region outside the system. So anything outside the system is called the surrounding. So anything outside the system, in here, anything outside the system, which is here, is called the surrounding. Boundary. The surface that separates the system from its surrounding. Boundary is just the surface that separates the system from its surrounding. So if you have, just like the previous example, you have a rigid wall tank. This is the gas molecule. The gas molecule, which is the system. Here, the mass outside the system, which is called the surrounding. So what separates the system from the surrounding is called the boundary. So this is called the boundary. So there are two types of boundary: movable and fixed boundary. Here is an example of a movable boundary. If you have a bucket, let's assume this to be a bucket, and this is a tap. Water is dropping from the tap. Let's say at first, at a particular time interval, the boundary was here. This should be the initial boundary. Let's name it to be U1. Within some time, the boundary will change. Let's call this U2, which is the final boundary. So this is an example of a movable boundary. So the fixed boundary is just the opposite of the movable boundary. A movable boundary changes with time. It is not constant. Coming down to types of system. There are three types of system: closed system, isolated system, and open system. Closed system, also known as control mass, consists of a fixed amount of mass, that is, no mass can enter or leave the system, but the energy in the form of heat or work can cross the boundary. So for example, we have a cup. And there's a lid is covered. The cup is covered with a lid. There's a tea in it. So we know that with time, the hot tea, it is a hot tea, the hot tea in this cup becomes cold, which means energy has been lost. Which means energy is lost. Energy is lost. But the mass remains constant. So in a closed system, the mass is constant, but energy is lost. Just like the example we gave here, a hot tea. Coming down to isolated system. An isolated system, it is a special type of closed system that does not interact in any way with its surrounding. An example of an isolated system is a flask. This is a flask. This is a flask. You have your hot tea in it. You have your hot tea in this flask. This flask, depending on the isolation of the flask, there is no mass is not lost. The mass is constant. Mass is constant. No loss of mass. Mass is constant. And energy. No loss of energy. No loss of energy. Because it is isolated. But there is no perfect isolated system. A perfect isolated system does not exist. With time, the tea in the flask, depending on the isolation of the flask, if the tea will get cold, so energy will definitely be lost. So please note no perfect isolated system. There's no perfect isolated system. Coming down the open system, also known as controlled volume. It is a system that has external interaction. Such interaction can take the form of energy or material transfer into or out of the system. So an open system is the opposite of a closed system. In an open system, for example, let's say this is a pot, and this is a bouncing. Let's assume this to be a beaker. Beaker, and there's water in it. This is the water level. And this is a bouncing burner. Heat is being applied. It has been applied. So with time, the molecules changes into vapor and it starts to evaporate. And with time, the boundary, this is the initial boundary, U1, and with time the boundary changes, U2. So from this example, we notice that mass is lost and also energy is lost. So in an open system, both mass and energy are lost. Properties of a system. Thermodynamic properties of a system. Any characteristics of a system is called a property. To describe a system and predict its behavior requires the knowledge of its properties and how these properties are related. Properties of a system are considered to be either intensive or extensive. So guys, intensive and extensive properties usually confuse a lot of students. I will try my best to explain these properties in the simplest format. Intensive properties. They are those properties that are independent on the mass of the system. They are independent on the mass of the system. Examples are pressure, temperature, density, concentration, specific heat capacity, molar heat capacity, molar enthalpy. While extensive property are those properties that are those properties whose values are dependent on the size or extent of the system. Extensive properties are additive. They are additive. They are additive properties. Their values changes with time. Examples are mass, momentum, volume, internal energy, entropy, enthalpy, and mode. So let's give an example. Let's assume this to be a room. Let's assume this to be a room. And in this room, we have pressure, volume, temperature, concentration, density represented as rho, mass, M, H as enthalpy, S as entropy. Let's assume this same room. Let's assume this same room to be divided. If you divide this room, let's make this intensive property, extensive property. What did we say that are intensive property? We said intensive property are those properties that are independent on the mass of the system. Guys, how I like to remember this is that from intensive property, from the word intensive property, from the word in, I know it is independent of the mass. While for extensive property, it is the opposite. It does not have the in it. It is dependent on the mass. I made a mistake here. So intensive properties. We say intensive properties are independent on the mass of the system. So in here, is pressure dependent on the mass of the system? No, pressure is not dependent. Pressure is independent on the mass of the system. Pressure does not depend on the mass of the system. Once you separate the room, pressure is not dependent on the mass of the system. So pressure is an intensive property. Is temperature an intensive property or an extensive property? Temperature is an intensive property because temperature is not affected by the mass. Once the room is separated, the temperature does not increase or reduce. So temperature is an intensive property. So is volume an intensive property or extensive property? Volume is an extensive property. Why is volume an extensive property? Because volume is dependent on the mass. Once you separate the room, the volume also changes. The volume changes. Is slashed into half. Volume is half. Mass. Is the mass an intensive or an extensive property? The mass is an extensive property. Why? Because it is dependent on the mass. Once you separate the room, the mass changes. So the mass is half. Is enthalpy an extensive property or an intensive property? Yes, enthalpy is an extensive property because it depends on the mass. It's an extensive property. Is entropy an extensive property? Yes, entropy is an extensive property because it is dependent on the mass. Now coming down to concentration. Is concentration an extensive or an intensive property? So what is concentration? Concentration, we know that concentration is equal to number of moles over volume. So is volume number of moles, is it an intensive property or an extensive property? Moles is an extensive property. Why? Because once you separate the room, the number of moles is reduced to half. So the number of moles is an extensive property. Is volume an extensive property? Yes, we say volume is an extensive property. So concentration is equal to number of moles, which is half, divided by the volume, which is half. So if you divide this, it is going to give you by 2 times 2 divided by V. This cancel this. So this is number of moles over volume. So what does this mean? It means concentration, C, is an intensive property because it does not depend on the mass. Let's move out of density. Is density represented as rho? Is density an intensive property or an extensive property? Density is mass over volume. We said mass is an extensive property because it depends on the mass. The mass is half. And volume is an extensive property because it depends on the mass. So solving this, it is mass over volume. So therefore, density 2 is not an extensive property, it is an intensive property. Density is an intensive property. So again, if you notice, I gave multiple examples. I gave multiple examples here where I said intensive property. Examples are temperature, pressure, density, concentration, specific heat capacity, molar heat capacity, molar enthalpy. So anywhere you see specific heat capacity, molar heat capacity, or molar enthalpy, it is an intensive property because it does not depend on the mass, because it is specific. It is specific. It's just concerned on 1 gram of that substance. So it is an intensive property. This is going to be the end of our class for today. Please, if you got value out of this content, please do ensure to hit that subscribe button. This is going to go a long way to make a huge difference. Goodbye for now, and hope to see you in the next video. Thank you guys.